Hello everyone. Today I wanted to walk you around the Hello World example in the PyDeclarative framework. PyDeclarative is a Python library for creating single-page applications or simply web applications. And there is a repository that I will share in the description of the video, as well as a technical paper that I will link as well, which describes PyDeclarative from maybe more detailed, but also more theoretically grounded perspective, and explains its advantages. But today I would like to focus more on the practical aspect and just show you around the Hello World application. It looks a little bit busy, but we will explain what all of this means. And I would like to show you first of all how to run this application before we actually click through all the elements. So once you have cloned the PyDeclarative repository and installed PyDeclarative using pip, either in regular or in development mode, you can go to the PyDeclarative directory and run the following command: python -m pydeclarative.server --module examples.hello-world. So this exploits the fact that you are in PyDeclarative directory in order for it to pick up the examples directory as a package. It could maybe use an improvement just to take in regular files. But it is what it is currently, and this is how you start the Hello World application. And then we can go back to the browser window. I will refresh this because the applications use a WebSocket to communicate with the server. So every time the server is restarted, you also have to refresh the window to reestablish the connection. And you can see immediately that the elements in the window are linked in different fashion with one another. So if you type some name, for example, in the input box, the text output gets updated automatically. If you click the button, you have a counter of the number of clicks. If you click this another button, you can have some dummy items being added on the bottom. When you do remove item, you now remove them. You can start a timer, which is triggering every second, and then you can stop the timer. Finally, you can add some lines here to the kind of poor man's terminal output, as I have named it in the code. You have also a model-based repeater display here, where you actually can append or insert items in the model or remove the items from the model, and the display is updated automatically using an item delegate. Finally, you have an example of actually executing some JavaScript triggered from the server, which in this case just disables all the buttons and re-enables them. Then you have something that is actually triggering an error, so it will just show in the console in the developer tools. Maybe we will show this later, or maybe you can take a look yourself. And here is something that is actually changing the declarative binding between the two reactive values. So currently this is addition, and here there's the result of addition being displayed. Then you can change it to multiplication, and then it displays the result of multiplication. So, well, that's the gist of it. It's not super complicated. Nevertheless, it already demonstrates a few of the core concepts of PyDeclarative. And now to the code. So this PyDeclarative application, it consists always of a root element, which inherits the div class, which essentially is a building block of the declarative UI hierarchy, and essentially a div is just it doesn't have any kind of graphical elements by its own. It's actually just a container. And the way it is done, you can also have some variables. So whenever a user connects or opens a new session, this hierarchy will be sort of recreated for each user and for each session, right? So this is a session specific construct. This class will be sort of instantiated, but in reality it will more like be transformed into a sort of declarative construct on the fly every time a new session is started in the browser. And then a peculiarity or a sort of special thing about PyDeclarative is that the child elements, they are also declared always as nested classes. And this is quite important because it sort of just abuses to certain extent the syntax of Python, and it just allows you in a very concise manner to just declare these derivative classes, and also have at the same time the possibility to overload the methods in those classes and to place variables in them in the derived classes, everything in place. So this would not have been possible if we used some kind of helper functions that would just take a class and make a declaration. Here it would be more clumsy. So we actually just use the class notation, and then there is essentially a processor which transforms this into the actual declarative user interface. So for example, this kind of syntax, it means that we will have a text input field labeled username or called username or having the username identifier. This is how we can refer to it from our code. And it will feature a placeholder text, and then it will feature a onloaded event, which means when the interface is created, this event will be triggered, and you would see here in the output somewhere essentially in all these messages that the username component has been loaded. Furthermore, we have a text output called message, and it has a dynamic text. Well, all these reactive properties, they are marked as a property, but defined using a method. And then this is probably the most important thing you have to learn about PyDeclarative, is that you can then refer in these dynamic properties to the all the other UI elements. So for example, if you want to refer to the username text input, that you just use the scope argument that is always passed to these dynamic properties, and you can just refer the field by name and then extract the property of the text input field. How do you know that it has the text property? Well, you can just go and see the definition of text input. And similarly, it has this onloaded event handler, just for the sake of demonstration, and also testing that everything is working as expected. Furthermore, you have the button, which is deriving the myButton class. So the myButton component is deriving the button component, and it just serves to have some customizations. So for example, it just makes the button larger and it colors the text red. And here you can see that you can achieve this specifying the CSS class and CSS style attributes. Furthermore, it has an isOutlineButton attribute, which can specify that it's supposed to use the bootstrapped outline button attributes or class. Yes, and similarly, we have also a myDiv component that also specifies some sizes. And this myDiv component will serve as these dummy green items that we are adding using a button. So the button has an event handler. So event handlers are specified just as methods. And again, you can refer to certain elements or variables using the scope and the identifiers. So in here, we actually go for scope root. So the root is our main element, and the counter is actually just a variable living in the root element. So we can increment the counter by 1. And what is important is that we have a message saying in the click counter element here, which is deriving the text output and has also a dynamic property text. This dynamic property, it refers this counter. And the power of PyDeclarative is that these values are always being propagated automatically, right? So this is why the name declarative. You just sort of declare what different components should display and do, and whatever state modification that happens is automatically reflected in all the outputs. You don't have to write explicit event handlers, but you can. So, for example, in the or you have to, even for the buttons, right? You have to specify the explicit event handler, and then the button does something, but then these changes to the underlying data, they are propagated automatically throughout the user interface. And as you can imagine, since we have already demonstrated here that you can derive components and nest components within one another, you can imagine that it can build, pretty powerful interfaces in a very in a composable and additive fashion. So you can build actually quite complete applications, right? And the other buttons that we have here are for adding the item. And as you can see here, it demonstrates how to dynamically load an item into the browser. And it uses this special function getEngine. So you can pass this X scope again to it, and it will extract actually the PyDeclarative engine out of the scope. And then you can load and you can specify what type of component in case of my div. And then you are specifying essentially that this is the top component, and because this load function is actually being called recursively under the hood, and you can specify what element should be the parent. So in this case, we are going to place it directly under the root, and then that's it. It's created and it's added again automatically. It will already appear in the browser. You don't have to do anything more. Here we just store it again in the dynamic nodes variable in root for the sake of removing it later. So with the remove item button, when it's clicked and we have some dynamic nodes, we just unload the last one. And this is how you do it. You just call the unload function of the engine. So using the same trick. We have already discussed the click counter. Here we have an example of actually displaying an image. So the red image is just a pill or pillow red image created here, and it's being displayed using the image component. All these basic components come directly from the PyDeclarative package, where we have imported everything from. So there is the image display. I will just briefly go back to the application to show you again, to remind you what we are talking about, right? So we went through this input button, input field from this counter button, add, remove item buttons, and the image, right? And now we go to the timer component, and the instance of the timer component will have also a counter, and the running is specifying whether it will be running after creation or whether it has to be started using a button. So we start with a counter 0 and a disabled timer, and whenever it's triggered, by default it has an interval of 1 second. We can also specify a different interval using the interval property. On triggered, it will just write my timer triggered in the console, and it will increment the counter. And since we have a dynamic output saying how many times the timer was triggered, again, it will be updated every time the timer is triggered without explicitly passing this information from the timer to this component. It will all happen behind the scenes. The start stop timer button essentially has a property called text, which displays either stop timer or start timer, depending on whether the timer is running or not. And we have also the onClicked event handler, which is essentially negating the current status of the timer. So if it's running, it's going to stop. If it's not running, it will start. Then we have this terminal component, which is just a dummy terminal. Normally, it will probably in the future be replaced by extern.js component, a much more powerful component. But currently, it's just a dummy pre-element based output. And it's just for the sake of demonstration, when you can add line to this terminal using a button, and when it's clicked, it actually sends a custom message to the terminal. It's an append message with a payload with field text, and the terminal is so constructed. If you go to the definition, today we're not going to go to the definitions of the individual components, but it actually can react to this kind of custom message, and it can append the message on the browser side in JavaScript. Finally, we have these model-based this list, and this is based on the repeater component. And the repeater component features a delegate, and the delegate is a sort of special child because it is marked with the delegate decorator, and it will be created dynamically. So this notation means that it's not just one delegate component there, but actually this will be created dynamically based on the model that we specified. And the model in this case, it starts with just 4 elements, and for each of these elements you can get model data, which is essentially these, and the indices, right? And the output of this delegate will always be just it will be a text output, because we derived text output, but it could be anything, and it could also have some nested hierarchy here. So again, it could have, like, you know, an entire application within it. And in this simple example, it will just display the indexed and the model data. And just again, as a reminder, this is what it looks like, right? So it displays indexed and model data, and you can append, insert, or remove items from this. And this is how you do. So when you have append button, on clicked, it just grabs the model out of the repeater element, and it just calls the append function of the model, where you can append directly the model data. And in this case, the model data is just this dummy text. For insertion, it's the same story, just we call the insert method instead, and insert at random position. And for remove, it's also again mostly the same flow. We just use the remove and remove an item from a random position. Lastly, we have some kind of empty div here. I'm not sure that we're using it for anything, but then we have also execute.js button, which again features a dynamic text depending on whether we have already enabled or disabled the buttons. And on clicked, it actually just flips that state. And importantly, based on that state, it actually executes JavaScript. So it grabs using a jQuery all buttons, and it sets accordingly the disabled attribute. So like this, you can issue any kind of JavaScript that you just want to run. You can also issue the command to do this from Python. And then we have another repeater example, simply how to repeat the items in a grid. And in a sort of a grid, or actually it's more like it should be maybe more called a floating repeater, because it just demonstrates that the delegate can feature the float start class from Bootstrap, and it will make everything just float to the left, as you can see. So when items have a fixed width, it will result in a sort of grid-like display. And maybe another name for this would be more accurate. And again, this demonstrates now that you can have nesting within delegates. So you have a div as a delegate, which features which is a card and has a float start class and has a certain width. And within it, actually, you have nested text output element with a card body class, and the text is actually determined dynamically using the model data, right? And here you have just a division by some unidentified identifiers. So this will fail as mentioned. There's another empty div, I think it was used for some kind of testing at the time. And here is actually the last part of the Hello World application. So you have these text inputs featuring the numbers and an operator, and you have a certain so the operator is defined, it's a text output, and the numbers you can input by hand. And you have two bindings. You have a binding that is executing a sum of those numbers specified in the fields, and the other that is executing the multiplication. And you have the change binding button, and it essentially runs an if block, and depending on what the text is, it actually switches it to the other operator, and then changes the binding. So this is quite important, and yeah, and I guess this is more or less it. So the other event here is showing that the root has been loaded. So yeah, so just going back to the Hello World application for a moment, just to illustrate also this point about numbers that you can specify by hand and also changing the binding. Okay, so I think this is actually it for today without delving into too much detail. Just a very brief first introduction. I hope it gives you a taste of what PyDeclarative is capable of. It's really quite powerful. It resembles a little bit Shiny for Python, but in fact it is meant as a general purpose application building framework, not really a dashboard builder. You can see this quite clearly in the way you can actually, nest and derive the components, and how you can actually just handle all of the events. And everything is just reactive and declarative. It's not based around these concepts of declarative or reactive values. You don't have to specify all these things all of the time. Everything is just reactive by default. And it's quite a bit more powerful, and there is quite a bit more that you can do directly in Python without creating components in JavaScript. Yeah, I think this is a convincing value proposal, and indeed I hope you give it a try. Thank you for your attention, and hope to hear from you. Thanks.